The section I'm going to be teaching is called Angles between Intersecting and Parallel Lines, which includes angles, parallel lines, and transversals. We have two lines here, first one called BC and the other one DE. These lines both sit on the same plane, which means they're coplanar, yet they never intersect. If you were to see something like this, where both of those things are true, then we would call these lines parallel. They are moving in the same general direction and have the same slope, but they have different y-intercepts and involve different points. Now, how do angles relate to parallel lines? Start by looking at the same two lines, but with another line that intersects both of them. This third line A is called a transversal line. Now think about the angles and how they relate to each other. Let's start off with the angle that's yellow. We know this angle is going to be equal to its vertical angle, which is opposite of the intersection. One way you can tell two angles are equal is if you see one dash on each or two dashes on each, and so on. Next, think about how these bottom angles are related to the ones up above. If you look at them, you can sort of tell they are going to be equal. If we were to use a protractor to measure it, you would get the exact same measure as the yellow one up above. These angles are called corresponding angles. Here's an example to help you better understand. Look at this diagram. We know from vertical angles that F is equal to G. We also know that F is equal to B because they are corresponding angles, and that B is equal to C because of vertical angles. So corresponding angles are equivalent, vertical angles are equivalent, and F is equal to C. So we would say alternate interior angles are equivalent. F and C are interior of the intersection in the two parallel lines, but they are on opposite sides of the transversal. We also know G is equal to B because they are alternate exterior angles. They are exterior of the intersection in two parallel lines, but they are on opposite sides of the transversal line. So now we know vertical lines are equivalent, corresponding angles are equivalent, and alternate interior as well as exterior angles are equivalent.